In this module, we are going to introduce the topic called predicate calculus. So what we have been studied so far is what is known as propositional calculus or propositional logic. Now, the reason we want to introduce predicate logic is because propositional logic has certain limitations. So let's look at this particular reasoning. All cats have tails, Cauchy is a cat, and therefore Cauchy has a tail. Predicate logic has no way to express this thing called all cats. It has an ability to say this cat 1 has a tail, cat 2 has a tail. It doesn't have the ability to say all cats have tails. And part of what we are going to do in predicate logic is to allow us to reason about these quantifiers. We'll call these quantifiers. All would be a universal quantifier and exists would be an existential quantifier. And by introducing that, we can express different statements and we can argue whether they are true or not true. So this is going to be the outline of our predicate calculus module. I will split it into multiple modules because there is quite a bit of stuff that we want to talk about, but this is the outline of the whole thing. I'll introduce predicate logic. I'll introduce what a predicate is, what a propositional function is, and I'll begin with that. Then I will introduce the two quantifiers, universal and existential, and then we'll look at how we can translate ordinary sentences that we might come across and convert them into predicate logic. We would need to do that in order to prove certain claims in those statements. I will introduce the notion of binding a variable. I will talk about negations and conjunctions, etc. associated with predicate logic. So let's look at this particular example. X plus 1 equal to 3 is not a proposition, and the reason it's not a proposition is because we don't know what x is, and so we can't evaluate whether x plus 1 is equal to 3. Question is, can we produce a proposition from it? Now we can produce a proposition from it by doing certain things. So to do that, first let's analyze what is the sentence itself. The sentence x plus 1 equals 3 has two parts. One part is this variable x, and then there is a property which is plus 1 equals 3. And this is what we are going to call a predicate. Grammatically, a predicate is part of a sentence that says something about the subject. In this case, the subject is this variable x, and you are saying that plus 1 equal to 3 is a property of this variable. So let's suppose that P denotes the predicate that says plus 1 equals 3. So we'll call this P of x. This is what we're going to call a propositional function. It has one parameter, and that parameter is x. So the way we can obtain a value for proposition from here is by assigning a value to x. So if I say what is P of 1? Well, essentially I'm asking the question 1 plus 1 equals 3. Well, that is false, so P of 1 is false. P of 2 is 2 plus 1 equals 3. That statement is true. Another thing we want to ask is, what is universe of discourse? Universe of discourse basically talks about what range this x is supposed to come from. So I had this proposition function x plus 1 equals 3. How am I supposed to get x from? Can x be 7? Can x be 3.5? Can x be equal to pi? What does x come from? So this is what we are going to call universe of discourse. So for this example, let's say we have a proposition function q of xy, and the property that we are representing by q is x is equal to y minus 4. So we can ask the question, what is q of 1 2, what is q of 1 5, etc. uh, what I want you to do first of all is figure out what these values are. Okay, now find all values of xy that make the value of qxy true. To do that, we have to specify where does x and y come from. And this is what we are going to call universe of discourse. It's a fancy name, or a domain under consideration of these variables. In general, if we have a proposition P that has n parameters, then in order to get the universe of discourse, I'll have to know where each of these values comes from. Once again, we have reached the check before you go ahead slide. Here, I want you to be able to distinguish between proposition and proposition function. We won't distinguish between them too much, but there is a difference between them. I want you to be aware of it. So for example, is x plus 1 a proposition or a proposition function? I want you to be aware of what universe of discourse of a variable is. Universe of discourse will play an important part in evaluating the formula because it's going to decide when we say something like for all x something is true, we would need to know where x comes from. Note that if I have a formula such as q of xy, so we have a proposition function that takes two parameters, the universe of discourse of x and y need not be the same. It could be the same, but it doesn't have to be. You could think of this as a type in a computer program. This is something that I have found to be useful. Some people will find it useful as well. So if I say x is an integer, I could think of it as a type, except that here universe of discourse can be very specific. So I can say it is universe of discourse is 3, 5, and 9. And that would mean that x has to come from one of these three things.